I had sent a message in the group mentioning what are the things that we are wanting to cover today. So we are still continuing with Unit 2 and one of the things that we had to cover as part of that is unit conversion, then talking about center, spread and shape of distribution, and then we'll talk about data representation. So data representation is more of a part of Unit 3. So we'll try to wrap up Unit 2 today and then we'll start Unit 3. So as you all would know, there are total 13 units as part of SAT preparation. So our goal is to cover one more round or one more iteration of all the topics by end of May, beginning of June. In between, if any of you have your SAT exam coming up earlier than that, and if there is a topic in which you need some help or some clarification, please feel free to send that information to me, and I'll figure out how do we address those topics ahead of time. All right. So now I see Aryan also has joined and Vishal as well. All right. So let's do a quick roll call. We have Aryan, Dev, Dhanushri, Praneeth, Chris, new Chris who has been there for some time. Then we have Prisha, Rehan, Sara, Srivatsav, Shravya, Sunarka, Vihan and Vishal. So some of the kids are still missing, but we'll actually get started. Anshu is not there. So is the case with Neil. Neil is not there as well. All right. And there are some new kids who are supposed to join, but okay, we'll get started. So first thing we'll do is we'll talk about, hey Neil. First thing we'll do is we'll talk about unit conversion. Then we will talk about I keep forgetting. We'll talk about center, spread and shape of distribution. Then we'll start with data representation, which is part of Unit 3. Any doubt, any question, anything that you want to call out before I start? I assume that is a no. Let's get started. So when you talk about unit conversion, what exactly do we mean by that? Unit is nothing but a way of measuring things. And what essentially we measure in our day-to-day life, those are primarily weight when you buy groceries, or sometimes you might be interested to know the weight of your teacher also, who is apparently very heavy. Then height or length, whatever you call it, or distance. And then we talk about measuring the volume. And the last thing is time. So essentially these are the 4 things that we end up measuring in our day-to-day life: height, weight, volume and time. Now there are different scales, different units, different ways of measurement that exist today. And essentially when we talk about some of those standard units, there are 2. One is called the metric system and another one is called US customary system. And most of these things you guys would be knowing. So as part of the syllabus, I'm just trying to cover them, and if there's any particular doubt that you guys have, we'll talk about that. So there are 2 systems of measurement that exist today. One is called the metric system and one is the US customary system. Interestingly, the place where we live, that has defined a separate unit altogether, which is called US customary system. Rest of the world uses metric system, including countries like India, Europe, countries in Europe, Middle East, everywhere. So most of the places, Africa, most of the countries use metric system. It's only US, or to be precise, North America is where you will see the US customary system is in use. Now, again, regardless of which system we talk about measuring these 4. So,
Your student is outside.
Okay, just one second. There's one. You can open the door. Just 1 second. There's one student waiting outside. close the door. Sorry. There was a little bit of interruption because of a country. Because Pranit has joined online today, so he was the only one who was supposed to be in the classroom. But anyways, yeah, coming back to the thing. So basically, when you talk about the systems for measurement, and essentially we talk about these 4 key elements or key things that we want to measure using metric system or US customary system. So as I mentioned, US customary system is a system used predominantly in North America, and rest of the world uses metric system for measuring these 4 things: weight, height, volume and time. Now the only good thing is all these elements of measurement, they have different units in metric system and customary system, but time is the only one which is treated by both the systems the same way. You have things like seconds, minutes, hours, days, weeks, months, and that is common between both the systems. So we'll not talk about time. That reduces a little bit of stress when it comes to knowing them all. So time part is common across both. Now, when you look at metric system, there is one song that I asked everybody to remember, and that is called milli, centi, deci, meter, deca, hecto, kilometer. So this song, millicenti, decimeter, deca, hecto, kilometer, that's a universal song that you can remember to know about all the 3 elements that you want to measure. Be it weight, be it volume, be it distance. So when it comes to weight, you will use gram. So it becomes milligram, centigram, decigram, and then this meter gets replaced with gram. Decagram, hectogram, kilogram. So millicenti, decimeter, deca, hecto, kilometer, you just replace meter with gram. So millimeter became milligram, centimeter became centigram, decimeter became decigram, meter became gram, decagram, hectogram, kilogram. And every unit is like 10 times. So 10 times of millimeter, milligram becomes centigram, 10 of that becomes deci, 10 of that becomes gram or meter, whichever unit you are trying to measure. So every unit is 10 times. The next one is 10 times of the previous one. Are you guys with me so far? Yep. So when you talk about distance, you are using meter. When you talk about weight, you have to take using gram. When you talk about volume, becomes liter. So this milligram becomes milliliter. You are replacing gram with liter, and this becomes milliliter, centiliter, deciliter, liter, decaliter, hectoliter, kiloliter. So volume is liter, weight is gram, and distance is meter. And that's what you will put here in this sum to find out the different units for the metric system. So metric system can be covered by just by knowing one song, which is milli, centi, decimeter, deca, hecto, kilometer, and you keep on replacing the suffix, the appropriate suffix for gram, liter and meter, and every subsequent unit is 10 times of the previous one. So if you're talking about gram, that is 10 decigram makes 1 gram. 10 of decigram makes 1 gram. 10 of centigram makes 1 gram. 10 of milligram makes 1 centigram. Yeah. So if you talk about how many grams, how many milligrams I have in a gram, so 10 times 10 times 10. So 10 to the power 3 milligrams make 1 gram. If you're talking about how many milligrams make a kilogram, so you're talking about 10 times 10 times 10 times 10 times 10 times 10. So 10 to the power 6. That many milligrams make a kilogram. And you can put the same logic, same concept for measuring all the different elements of measurement that you are concerned about. Is this part clear or is it confusing? I'm trying to rush through this little fast because I know most of you know about it. I'm just trying to make sure we're not skipping anything, but at the same time, we're not spending a lot of time on this either. Is everybody with me? Alright. So, metric system we covered. We talked about weight, volume and distance. Now, and as long as you remember the sum, you would know from where to where. Let's say if you have to convert decagram into centigram, meaning centigram is a smaller unit, decagram is a bigger unit. If you have to convert decagram into centigram, meaning how many halves we are talking about? 1, 2 and 3. So 1000. So if you have to convert centigram to decagram, you will multiply by 10. Sorry, if you have to convert centigram into decagram, you will divide by 1000. If you have to convert decagram to centigram, you will multiply by 1000. That part is clear, right? You guys would have played with this enough, so I'm just skimming through this. Yeah? Now, let's come to the interesting part that we have to deal with almost on a day-to-day basis, which is US customary system. US customary system. I mean, I don't know if that is the right pronunciation or not. I'll say US customary system. So first let's look at the distance. So when it comes to distance in metric system, we talked about millimeter, centimeter, decimeter, meter, decameter, hectometer, kilometer. Now when you're talking about distance in customary system, it starts with inches. Inches, foot or feet depending on singular or plural, then yard and then miles. 12 inches make 1 foot, 3 foot make 3 feet make 1 yard, and I think 1760 yards make a mile. So this is the conversion. So this is where US customary system is a little different, a little more cumbersome when it comes to knowing about it all. You have to know this conversion. So how many inches make a foot, how many feet make a yard, and how many yards make a mile. That part you have to remember, this conversion. As far as I know, I think in your SAT exam, if you have any question around this one, they mostly give the conversion, but it's always no excuse to remember this, because in case they don't give, you're not stuck with one easy question that could have given you, a good opportunity for scoring a better in a better way. Yeah, and this will be one of the easiest questions to deal with. So you certainly don't want to miss on getting some extra brownie points by memorizing this. Okay, so 12, 3, 1760. Does everybody know about this, or you were kind of forgetting about it? Okay, I don't know if you remember this, but if you don't, just spend 5 minutes, that should be okay. So this is the distance part of it. Now if you go from distance to the next one, let's say weight. If we talk about weight, let's see who all remembers this. If we talk about weight, so here we talk about ounces, then we talk about pound, then we talk about what is the next one? When we talk about the weight, we talk about ounce, pound. So this ounce is the dry one. I mean, you have something for fluid, and one, when you just say ounce, you're talking about with respect to the weight. And then, yeah, Vishal, what is the next one?
Tons.
Say that again?
Tons.
Tons, correct. And how many ounces make a pound? Yes, Chris.
16.
16 ounces make a pound. How many pounds make a ton? Yes, Chris.
2000.
2000. Yeah, that's correct. So, distance we talked about inches, foot, yard, mile. When we talk about weight in customer system, you're talking about ounce, pound, and tons. So 16 ounce make a pound and 2000 pounds make a ton. Now comes the next one, which is volume. When we are talking about measuring something which is not solid. So that's where you deal with some of the terms which are similar to what we have seen with respect to weight, but the interpretation would be different. So here also you have ounce, but that's called fluid ounce. Okay, so that's the only common thing. So let's look at what are the things that we talk about. So start with the cup. I'll give you one toned down version of the conversions, and then another one would be the extended form of it. So let's start with the cup. So start with let's say pound. Ounce. 8 ounce make a cup. 2 cups make a pound. Sorry, not pound. 1 pint. 2 pint make a quarts. Quart, I think that quarts. And 4 quarts make 1 gallon. So yes, starting with the ounce, that is the smallest units for now. It's a toned down version. So 8 fluid ounce make a cup, 2 cups make a pint, 2 pint make a quart, and 4 quart make a gallon. So the gas that we fill in the car, that's 1 gallon is actually 4 quarts. Or we all know, right? A quarter is always 1/4 of something. So you can relate it with that. So 4 quart make a gallon, 2 pint make a quart, 2 cups make a pint, and 8 fluid ounce make a cup. Now if you want to further break it down, start with teaspoon. 3 teaspoon make a tablespoon. And 2 tablespoon make 1 ounce, fluid ounce. So basically, this is what is a toned down version. And if you want to add some missing elements or add further smaller units, you start from here. So 3 teaspoon make 1 tablespoon, 2 tablespoons make a pound, make an ounce, 8 ounce make a cup, 2 cups make a pint, 2 pint make a quart, 4 quart make a gallon. So this is the relationship here. If somebody asks you to find out how many cups are in gallon, you know how many times you have to go. 4 times 2 times 2 times 8. That's how you can figure out how many cups will a gallon have. Is this part clear, understandable, or something that you would want me to stress on? Clear? Okay. So I'll take that as a no to continue further on this one. So this is on the unit conversion. There's one more thing. Mostly we don't talk about converting from metric system to customary system. One thing that we come across very commonly is centimeter to inches. This is something that you will see very frequently because this is something that we deal with more often, right? The scale that we use, you would have seen on the scale, on one side you have centimeters written and one side you have inches written. So there mostly you will see that if you are looking at a big scale, you will see 30 centimeters on one side and 12 inches on other side. So roughly if you see, it's 2.5 centimeters make an inch, 2.5 centimeters make an inch, or to be more precise, mathematically you will see 1 inches equal to 2.51 centimeters. So you can use this conversion if you are required to deal with it. Alright. Now let's go to the next part of the plan, which is around center, mean and spread of data and understanding the shape of distribution. Center, spread and shape of distribution. Now this again revolves around three key things that most of you would be knowing. If I just call it out, and I think I covered this in one of the class very recently, so I'll probably not spend much time on this one. And mode. I think I covered this one very recently. So if you look at mean, this is nothing but the average. As simple as that. This is the average. If you have few numbers that you're dealing with, the average of all the numbers is that is what is your mean. If you're looking at a median, median is nothing but if you have, let's say, 5 numbers, 8, 6, 9, 11 and 17. If you have to find out the median of this, first thing you do is arrange them in increasing or decreasing order and then find out the one which is in the middle. So if you're talking about odd number of numbers, here in case of 5, you will look at the third element after rearranging them. If you are talking about even number of numbers, so let's say if you have 7 also here, then you will arrange them in increasing or decreasing order and then pick up the middle 2 so that you have equal number of numbers on both the sides after selecting the middle ones. So here in case of 6 numbers, after you arrange them, you look at the third and fourth number and find out the average of that. That will be a mean. Is everybody clear with that mean and median part, or would you want me to talk about that any further? Okay. Shravya, no confirmation? Are you clear about that, beta?
Yes, sir.
Okay. So mean, median, and then when we talk about mode, mode is nothing but in a set of numbers that you have to deal with, the one that has maximum occurrence. Let's say if I'm talking about 8, 6, 8, 9, 18, 6, 14, 6. Here if you look at this one, you see 8 occurring twice and 6 occurring 3 times. So basically your mode would be 6 because 6 is occurring maximum number of times. Now if you look at the conceptual layout of this, mean is nothing but it gives you the average. Very simple. If you have 10 kids in a class and if you are trying to find out the average age, you will find out the average, and that you can call as mean also. It just tells you what is the average age of the class or what is the average that you are seeing based on data that you have. Median is nothing but it is another way of finding out the thing that is probably the average or the center of the data. So that's why you first arrange them and then you look at the central part of it. So that's why if you look at mean, that gives you, look at the spread of data this way. You have some data with, let's say this is your average, this is your mean. Then you have some value higher than this and you have some value lower than this. So mean is nothing but it defines the center of all the information that you have. Similarly, median, if you look at it, what did we do? We arranged them and we looked at the central part of it, which will be pretty close to the mean value most of the times, barring situation where you are talking about extreme numbers or outliers. But in general, your mean would also represent the central part of it. Now when you look at mode is little different. The interpretation here is, you are trying to find out the number which is occurring in the set of data maximum number of times, meaning that particular number has maximum influence on the overall behavior of the data that you are talking about. This gives you average, this tells you what is there in the center, this tells you what is the number that can influence the overall data the most. See, 18 is a lone child here. It cannot do much. Imagine you're talking about hundreds of records, and if you look at a mode, let's say 6 is the one which is occurring probably 25 times. So this guy can influence the overall average of the set of data that we're talking about. So that's where mode is little different, interpreted little differently compared to other two, which is deriving mostly the center of the record that we have. Is that part clear? So the kind of problem that you will deal with would be this. You might come across a question which will say that I have, let's say, 15 records or age of 15 kids or score of 10 by 15 kids in a 50 marks exam. People got, let me not say 15, I'll have to write a lot. Let's say we have 10 kids. Okay. And you'll be asked to find out the mean of that, median of that, mode of that. You know that mean will be average of that. Median would be, again, you'll arrange them and find out the one in the center. Since we're talking about 10 scores, you'll look at 4 on this side, 4 on this side, and you'll pick the center 2 number and find the average. That will be a median. Again, mode will be the one that is occurring the maximum number of times, and as you can see from the record, this is your mode. Up to this much is fine. Now, where they will tweak it, they'll say, okay, find out the missing number that can change the range by 5 of the set. So now, I'm saying, this is the marks of 10 by 10 kids in the class. Out of 50, out of a 50 marks exam, 9 marks are given to you. Find out the value of X, the 10th kid, which could alter which could increase the range by 5. Now, first thing is, if you have a set of records, what is the range? Smallest value and the maximum value difference, correct? Yeah. So what is the current, if I did not have this one, what was my range? It was from 8 all the way till 44. So my range was 36. It says, what is the value or what is the marks scored by the last kid which is impacting the range by 5 or increasing the range by 5. If it says impacting the range by 5, then we are talking about two scenarios when this range goes from 36 to 31, and second scenario is when it goes from 36 to 41. Now, see, it will not go to 31 because even if you look at this being a smaller number, your range is already defined. You cannot go below that. This guy cannot influence these two numbers. These two numbers are scored by somebody else. This guy can only increase it. So that's why 31 is out of the equation, and you're talking about range increasing to 41, meaning this increases the range by 5 more. Now that means 8 plus 36, that was my range. 44 was my range before. 8 to 44 it was going. Now we're talking about increasing the range by 5. That essentially means this is not 44, this is 44 plus 5. That's the only way your range could increase by 5. So this is nothing but 44 plus 5, 49. So I'm not anticipating you guys to come across a lot of cryptic problems for this topic, but you just have to look at the numbers, think about what is the ask. Are they talking about average? Are they talking about range? Are they talking about finding out the unknown depending on what information they have? Are they talking about let's say they might say that, okay, fine, I have other, saying find out the missing value that helps to determine the mode. Now, the confusion that we have is, we have two value with 42 and two value with 44. So, it's in a confused state. Now, what are the answers we are talking about? We are talking about either it could add a 44 here or add a 42 here. That will help you determine the mode. And then they will add a disclaimer saying, okay, fine, add the maximum possible value to help you determine the mode. So when they talk about maximum, you have two options, 42 and 44, both have two occurrences. Now saying find out the maximum value, that means you have to pick up the higher of the lot, and that is how you end up putting 44 here. Is that part clear? Yes, Chris.
Yeah, I just had a question. Like, if you're like asked to like find the mode of like a set, so then in this question, like we saw, like there were like 242 and 244. So then, what would the mode be considered in that situation?
So if you have only two data, right? I mean, if you had only 9 records, and out of that you have to find out the mode, then essentially you are finding two modes here, 42 and 44, because both have same number of occurrences, and there's no ways for you to differentiate between this and this. So the most ideal answer would be 42 and 44. That is the mode, because both of these numbers are influencing your overall behavior of this one. And then in the question they will ask you, find out the value of the higher mode, then you will pick up this one. If they say find out the value of the lower mode, then you will pick up this one. But if any of you are aware of any third method which helps you find out the mode when you have two options to pick from, I would certainly be interested to hear that. Anybody? Dhanushree, Vishal, Vihar, anybody? Praneeth?
No, sir.
No? So essentially, no, see, this is, yes, Chris.
No, I just had a question. So when you were talking about increasing the range by 5, wouldn't it be also possible to instead of adding a score of 49, would you be able to add a score of 3, because then it also increased the range, because 3 to 44 becomes, it also increases the range? Would that be possible?
Yeah, you are just making one of your friend fail. That's it. That's a valid answer. That's possible. Yeah, no denying that.
Okay, thank you.
All right. So this is on the basic mean median mode and related problems, and these problems will be more of a word problem where you have to just, without much of a calculation, you just have to use my most boring technique to solve it. Read the question enough, because there will be some hidden clues in the question, okay? Because these questions for mean median mode cannot get complicated. These are pretty straightforward ones, that too for kids of your age. So it's mostly to do with finding out any of the hidden clues. As long as you find the hidden clue by reading the question enough, and then you put your head around that, you will be able to solve it. Where you could go wrong is when you get influenced by Nike. Just do it without reading that in detail, because these questions cannot get you confused. The only way you can get confused is by not getting each and every clue or each and every possible clue from the question. Okay, so get into the habit of, I mean, there are two basic thumb rules that I prescribe. One is reading the question enough before you start doing it, and second thing is reviewing after you finish what you have done. See, it's not about, it's a choice between quantity and quality. Let's say if you have 30 questions in exam, you're okay to solve 28 questions correctly and still leave 2 questions, compared to doing it all 30 and making 5 mistakes. Ultimately what will count is 25 being right here and 28 being right here, and this is certainly a better score. So always focus on making sure that you try doing it right rather than doing it all. I mean, if you do it right and do it all, nothing like it. I mean, that's the aspired state, I assume, for all of you in your final SAT exam. But then when you have to choose between these two, you should go for this. And that's where spending time with the question and doing your reviews, or basically planning your test in a way that you keep enough time for yourself to review, that really helps. Yeah. So all of you who have your SAT exams coming up sooner than others, I would say do a lot of practice and make sure that you kind of get into the habit of reviewing, planning, reading the questions in detail so that you minimize the chances of mistakes. Yeah. Alright. So we move on to the unit 3 now, which is nothing but data representations. That is data representations. Now, what do you mean by data representation? We deal with data, we do operations, we have learned all different possible calculations, be it addition, subtraction, multiplication, division, finding out percentages, finding out interest, finding out different, doing different calculations with respect to geometry, trigonometry, whatnot. Now comes what exactly do we mean by data representation? Now think of a situation where you have a lot of information. Meaning, let's say if I just randomly put 8, 16, 4, 9, 82, 75, 68, and likewise I have hundreds of records here. What does it mean? First of all, it means nothing. So I have to represent the data in such a way. If I say that, okay, this is the age of all the people living in my neighborhood, this still gives you some clue that, okay, now we're talking about age. So that is one information we are adding to it. But then my neighborhood has a lot of people staying next to my house. Right? Obviously, in my neighborhood, we have a lot of people, right? And all possible age groups. So I'll probably end up writing 100 numbers, and each number representing the age of one other person living in my neighborhood. Now, that still is a lot of information. It's good to have that information, but what can I do with the data? Let's say if I want to organize a small event. Let's say I want to put up a small stall for lemonade. Would a 75-year-old person come, or would a 4-year-old kid come? Obviously, we know that younger kids will be more excited to come to a lemon stall compared to an elderly person who is trying to avoid sugar. Correct? So that being said, the information that we have, it has to be better represented. It has to be more organized. It should give some intuitive or conclusive view from the information, so that it can be used by people in a more efficient way. Now think of another thing. Let's say every year in every company, the big bosses of the company, they say, okay, fine, we are going to roll out bonuses for people based on their performance. Now imagine a company with 5,000 people working in it, and if the CEO of the company has to look at 5,000 people's performance and then decide on bonus, that's going to be a mammoth task, not easy. Instead, and also we have to look at CEO has a lot many other things to do. He or she might not be able to spend that much time to go through each and every individual's performance details and then make a decision. Rather, he or she would want to say, okay, fine, what percentage of my company has high performers versus what percentage has average performers and how many are below performers. That is how I will decide. So if he gets an information in this form, say, okay, fine, out of 5,000 people, let's say performance category, and then rating, let's say. So, this is count. So out of 5,000 people, if he gets to know that, okay, high performers are, let's say, 200, and then medium performers or okay performers are, let's say, 4,700, and low performers or non-performers are 100. This makes the CEO's job much easier. He'll say, okay, fine, I want to give, let's say, $500 as extra bonus to these people. These people are doing okay, this is my mass, I will probably give $200 as extra bonus. And again, I'm making it up, okay? It has no relevance to any company's decision making ability. And then say, okay, these people need to be knocked off. So you guys keep hearing about layoffs, other things. This is where they become the obvious pick for those bad news that we talk about. Correct? So when the CEO has information in a more structured way, in a more intuitive way, where he or she can make a decision with less effort without compromising on the actual quality of the decision, this helps. And this is called, there's a difference between this data and this data. This is called unstructured data, this is called structured data. Yeah? Does it make sense? So when you talk about data representation, you're essentially talking about the exercise where you pick up the raw data, which is unstructured, then do massaging of the data and put that in a representable form, which can be very helpful in making decisions for the people, or it could give the right view to right people based on their roles and their responsibilities to make a decision appropriately. This could be a view for the CEO. There could be a different view for the respective managers. They'll say, okay, fine, I have a team of 12, which is a subset of this, and out of 12, this many are high performers, this many are below performers, and this many are average performers. And this is how I will give the recommendation back to the leadership to consider them for different bonuses. So different people based on their role will have different view of the data or different view of the representable or structured data to make a decision out of it. So that's the key importance of what is data representation. What does data representation mean to us, and how is the journey that goes from unstructured data to the structured data. And we'll talk about different tools and techniques that are in place for getting to this shape. And this is not the only shape, okay? This is just the tabular form of data. There are different charts and graphs that we'll talk about. But is this part clear to you guys? Conceptually. Okay. Now, unfortunately, we all have gone through a very bad phase of life. I mean, not only us, the whole world went through it. That was COVID. And you would have seen that from every place, every country, every state, every city, there's a lot of bad information coming across. And people had to understand this, digest that information, process it, and there were different people to make different decisions, right? I mean, like the medical, the first responders, they had to plan it that way. The government had to plan enough infrastructure, medicines, vaccinations, whatnot, right? I'm talking about COVID if I did not say so. So, and there was too much of information coming across. And that would have been a nightmare if it comes in an unstructured form. If you guys remember, I have seen this chart so many times. Where every bar is representing a day, let's say, Jan 1, how many COVID infected, how many casualties, how many new patients, how many recovered, and then Jan 2, Jan 3, Jan 4. And this was, that you would have seen, I think there was something called a Voldometer or something, I don't remember exactly. But that used to give you day by day view. And from that people used to also derive a trend. Okay, this seems to be coming down. This is coming down, and then suddenly a spike, a new variant formed. So this kind of graph you would have seen during the COVID days. It was flashing all the time on internet, and we used to look at that to get that peace of mind. Is it coming down? Is it staying stable, or is it spiking up? Right? This is nothing but called a bar chart, and that you will see different kinds of bar charts, pie charts, line graph, plot chart, histogram, whatnot. We'll look at different piece of information and different tools. These are called tools, different charts that we come across. And some of you who are familiar with Excel and PowerPoint presentations, you would have seen the different options you have for plotting data in a more intuitive way using these tools. So let's look at some of them. But before I go to the different types of charts, any questions? Rehan, Savya, Neil, Sarah, Dhanushri?
No.
Okay. All right. So Mandeep, you are 13 minutes early for the class. You will end up learning a lot of tough concepts. Okay, you got scared. See what's up? Very quiet today. Are you with me?
Yes, sir.
Oh, okay. I'm sure, some of you would have heard this from me in the past, but as part of the second iteration, I still have to cover all the concepts because I'll not go with assumption that everybody knows it. And that's what I meant by doing multiple iterations of the same concept. Sometimes it will get a little boring for you guys because you already know it to the next level, but if I'm to be believed, there is no harm in doing revision. Okay? All right. Now let's look at some of the charts. We'll start with something that you would have seen in Walmart so many times, which is called pie. Right? This is pyramid pie. So, and we always talk in general, right? I'll get a bigger piece of the pie. I'll get a smaller piece of the pie. What does it mean? This pie is to be distributed among the people in the family or among their friends. Who gets how big a piece of the pie is always the point of contention. But in mathematical world, if you look at it, to us with maths, this is nothing but a circle. And every circle is made of 360 degrees. So this pie chart is used to represent the split. Let's say I have a class where let's say among you guys itself. So we have how many students right now? Maybe 15? 15 kids in the class right now. Out of 15, I have, let's say, 8 boys and 7 girls. I'm just making it up, okay? So 8 boys and 7 girls. If I represent this as this, say, okay, fine. This part of the pie is boys, this part of the, or I think I said 8 boys, so this is boys and this is girls. So we have 8 boys and 7 girls. Again, I might be wrong with my counting, I just assume something. Now, how do you decide on this one? So you have to look at this. Total kids, we have 15 and 8 boys, 7 girls. So you know that this 15 is to be distributed among 360 degrees. So what is the boy to total kids ratio? 8 out of 15. How many degrees of this pie it will take? This will determine how many degrees of the pie it will take. So once you calculate this, you get 8 times 15 to the 30, 15 4 to 60. So 24 into 8, whatever it comes to, 8 4 to 32, 8 to the 16 plus 390. 192 degrees. So 192 degrees of the pie will be your boys, and remaining 360 minus 192, this will be your, so 160 plus 8, 168 degree will be represented for girls. So this is nothing but, see, the same calculation, whatever we have here, we can do it mathematically and find it out, okay. We can also talk about this in percentage also. 8 by 15 times 100 will give me boys percentage. 7 by 15 times 100 will give me girls percentage. So we can represent that in percentage or we can represent that as a pi, which is a much more intuitive way of representing this, right? By looking at this itself, it gives you that view. Let's say in this class we have kids from different age group. Let's say we have kids from 9th grade, we have kids from 10th grade, and we have some kids from 8th grade also. So then I'll say, okay, I'll not say boys, girls and this thing, I'll say 8th grade, sorry, let's say 9th grade is maximum, 9th grade, 10th grade and 8th grade. Just by determining what is my percentage split of different age group, by looking at this graph itself, we can figure out that okay, 8th grade kids are least in numbers in this class. Similarly, 10th is probably the highest among all. This is in between the two. So this gives you an intuitive view of the same data that you would look at in a more unstructured way otherwise. So this is just one of the tools which is called pie chart, and again you will look at this like a circle and then use that circle 360 degrees to determine who will own what degree of the circle or what percentage of the pie. Is that part clear to everybody, or am I making it sound tricky? Okay, Praneeth is okay, he has heard me enough, he is tired also. Everybody is okay? Alright. Okay. Alright. So Joyce, you are a little early for the class, probably 7 more minutes. After that we'll start for you guys, okay? You can hang around there, but yeah, it'll not be of any, it'll not make much sense to you. Okay, yes Ame, same for you. So this is one of the tools that is called pie chart that we use for a more intuitive representation of the data in the form of a pie. Since it looks like a pie, that's why people were happy giving it a name called pie chart. It's a chart, looks like a pie, and that determines or that gives you a more intuitive view of how you are looking at the data or how you can interpret the data. Let's say if a new teacher joins a class, let's say instead of me somebody else tries to teach. I mean that will not be the case, but I'm just making it up. Let's say tomorrow somebody joins the class and he or she doesn't have much idea about kids are from which all grade. Just by looking at the pie chart, he or she can make out, okay, there are some kids from 8th grade also. So when he or she tries teaching the concepts, she has to keep in mind that, okay, I should not be talking with the assumption that everybody knows everything. I have to make sure that if I'm teaching a concept, that concept is understandable to somebody from 8th grade as well. Yeah? Alright? So this is one of the tools that is called pie chart. We will just look at one more called bar chart, and then probably we'll disperse for today, and then we'll look at rest of the tools in the coming class. So Yamatli ji, आ जाइए a class is going on, so आप लेके आ जाइए ना. Okay, चलिए, bye bye. Yep, sorry. So the other one is called bar chart. Now let's look at a data. Let's say let's talk about a situation where we are talking about the temperature, the maximum temperature in McKinney in last 7 days. This was Monday, this was Tuesday, this was Wednesday, this was Thursday, this was Friday, and weekends are so hot. Thursday, Friday, Saturday, Sunday. And this is, let's say 10, 20, I'm talking in Celsius right now, okay? This is 30 and this is 40 in Celsius. So just by looking at this graph, so this said Monday was 22 degree, let's say. Tuesday got cooler, became 19 degree. Wednesday became 30. Thursday was 29, bearable. Friday, all of a sudden, there was a cold breeze and it came down to 12 degrees. Saturday, Sunday, all of a sudden became very hot. Just by looking at this, there are a couple of things that you can derive. Say, okay, temperature is very much fluctuating. That means we should go prepared wherever we go out. We cannot go in shorts and all of a sudden we realize, oh, we can 12 degrees and then you start shivering. So this information, if I just put that in the form of a table every day and the temperature, it will look raw, but the problem is it will not give you very intuitive view. You have to read a lot of information to make a conclusion out of it, but here by looking at the graph, you can see the fluctuation, and just by looking at the graph, you don't really have to look at the numbers. You can see that, okay, Saturday, Sunday is super hot. Maybe this is time to go to pool. So this helps you make those decisions which will be difficult to make otherwise. So we looked at pie chart, we looked at bar chart, and you can think of different scenarios for plotting this information. When you're talking about information being scattered or for different scenarios, it could be for days, it could be for a class. I mean, I can say, okay, fine. I can also have a bar chart saying, okay, every kid's performance in different tests. So I pick up one kid and say, okay, fine. First test how much, second test how much, third test how much, and based on the trend, I can see whether the kid is consistent or improving or has a lot of scope for improvement. Yeah. So with that being said, I will pause here. Any questions?